Hello, I'm Ken Weller, and I'm here to talk to you a little bit today about the videos that I've been posting on my YouTube channel. YouTube channel is New Tech Inventors, which is the name of a business that I started this year. The business came about from an idea that I had last December. And last December, I decided that I wanted to try to make a device that I'd been envisioning, and I needed to be able to make some complex parts that interacted, and so I was trying to figure out how I could make these parts, and the 3D printer came to mind. I was aware of the 3D printer, but I wasn't aware of where it was, what stage it was in, how it worked, and all of that. So I purchased my first 3D printer in December of last year, and with that printer I also downloaded the free software from Autodesk 123, the design, and then I took that software and designed some of these various parts that I have here that were going to be part of my project. So in designing them, I also have a video that hasn't been posted yet, but that will go through a little more of the detail of how I designed these parts using the Autodesk 123D design software. Again, it was downloaded free of charge on the internet, and it worked very well. It took me a little while to learn how to use it, and thanks to a lot of other YouTubers that had posted some instruction out there on some of the various commands and things, how to do certain things, were vital to me being successful in designing the parts. Once they were designed, then I took them through a series of a series of 3D printers that I purchased, and I started out with some small inexpensive 3D printers and made a lot of prototype parts, and in the past 4 or 5 months I have perfected those parts and come up with good designs, and was ready to start producing some of these parts in quantity, and to build an inventory that I can sell. One of the printers that I'm utilizing a lot is this little Kingroon KP3 printer, 3D printer here, and the reason that I like it is because it takes up a very small area. I have a video online now that you can look at where it shows 8 of these printers in about an 8-foot area of bench top. So when you can get 8 of these printers in an 8-foot span working, that takes up a lot less space than something like the Arnett printer, which you only get about 3 or 4 of those, approximately 4 of those in a similar area. A couple of things about the Kingroon. I've done several videos on the Kingroon as I've come along, and in addition to its size, it's very inexpensive. It assembles in less than 10 minutes. There are very few parts you just one whole assembly, and I have an unpack and assembly video out there. And then the alignment of it is very simple. A couple of key things is to make sure that this arm is parallel to your build table. If it's not, you're going to end up with something other than a rectangle or a parallel. It's going to be more like a parallelogram and be skewed, so you have to make sure that's aligned. And then of course leveling the bed. One thing I like a lot about it is this magnetic pad. One precaution, if you're going with this printer and getting ready to use it, run some small parts on here first and cycle this pad on and off multiple times, because if you put a large part on it and you have a little too much adhesion, it is very difficult to even get the magnetic part off. This actually can stick, and when it does, that happened to me early on, and you can see it can damage the sheet in the build area. One thing, if you do get a damaged place on here, you can always offset this and print with it in that situation, so you're not printing over a damaged area. So that's a little tip there that keeps you from just having to throw these things away once you get a scratch on them or something. But once you get get this thing to where it's run through a few small simple prints on and off several times, then you can print quantities. I print 6 of these parts at a time on this printer, something like a pattern like that. And I have a video online showing the printing of multiple of these printers printing these parts, and then it peels off very easily. The parts come right off. I very seldom have to use a scraper on it, and like I said, I don't have difficulty getting the parts off of it. Leveling is very easy with these knobs here. The only disadvantage I've seen so far is that when your bed is in the forward position, it covers up your touch screen here and makes it a little difficult to do something with that. But other than that, it's turned out to be a really good printer, and once you get it set up and running, I run a lot of these parts through this printer. Disadvantage is, of course, the size. This is another part that we print, and as you can see, there's no way that it can print on this printer. The bed, 180 by 180 millimeters, is just not large enough to print this part. However, this part prints very well on something like the Arnett. So I think that's about enough on the King Rune. I believe I've mentioned everything. It does work very well with power interruptions. Starting back up, I've had power failures. I'm operating this business by myself out of my home, and I'm in a bonus room area where I have limited outlets. And the other day I was attempting to run 16 printers, and when the 15th printer came online, it blew that circuit. So all 15 printers that were already running stopped until I could go down and reset the breaker and come back and restart them. They all restarted well, and every part that was in the process at the time of the power failure came out fine. So it's good on handling power interruptions. So that's a little bit about the King Rune. Oh, one other thing I wanted to mention about it. It comes with these rollers for the filament. And what I like about that is that you can put your roll of filament in there and it just feeds it. Everything works fine. Another good thing is if you have wider rolls of filament, you just set them out and it works fine with that. Now with the Arnett, I'm going to set it down here and the CT4X printer. It's a good printer, and I use it for printing larger parts. This part here, as you can see, takes up most of the bed area on the Arnett printer. So I print these parts on this printer. And this particular part takes about 12 hours to print. The 6 of these running on the King Rune takes about 10 hours to print. So what I'll do is I'll try to schedule my print cycles so that I can run the printers and let them run through the night, set them before I go to bed, and get up in the morning and go up and take the parts off and restart them. I don't even have to remove the filament. So some of these printers will run 36 or 48 hours at a time, a cycle. I have about 7 or 8 printers in there running right now that have been running for over 24 hours, and they'll continue running through the night tonight, and then I'll continue to run them and actually bring about 6 more printers online with them tomorrow with some other parts. Okay, the Arnett, one thing about it, I'm going to make an adapter for this because this is made for a standard spool. It's not adjustable, and you can't put this large spool on there. So I am going to make an adapter because I do have a lot of filament on the wider spools as well as the standard size spools. So with the Arnett, I'll need to print a extended piece here to handle that filament. Other than that, this printer works real well. It also takes very little time to put together. Takes longer than the King Rune, but not that long. It comes pretty much assembled, the different assemblies, and then you just put the frame together and mount these pieces, and you're pretty much ready to go. So this is a quick assembly printer. Some of the first printers I had required hours and hours of putting every piece of the frame together. They were normally acrylic frames, and I still have a lot of those printers, and they're still useful and still run parts, but they're a little more difficult to maintain, especially the alignment and everything. Once you get these aligned and set up, they don't need a lot of work. What I do like to do is when I'm printing, and I would suggest that everybody do this if they aren't already, When you finish a print job, take your, and you're ready to remove your filament, remove the filament from the printer before you take heat off of the nozzle or the hot end here. And the reason for that is that you can release pressure on the extruder here and pull that filament out. And what you can see this thread on the end of this one. This is one that I pulled out of a printer. The reason for that is if you just cut the filament off, then that piece of filament that's in there, if you don't use the printer immediately, if you let it sit a day or two, that filament's going to start to get brittle and it will break and get stuck in there, and you'll end up having to take the tube off and to get the filament out of there, and it's just a mess. This way, if you pull it out, you pull it all the way from the nozzle and get all the filament out there. The next day you're ready to start, and if you're starting with a different color filament, you don't have to worry about purging the old filament. You just put the new in, push it all the way down to the head, and let it extrude for a few seconds to get any residual of the previous filament out, and it's ready to go. Be sure and be aware of the different temperatures and stuff. When I make these parts, these black parts are PETG filament. This is a PLA filament. This is a PLA filament, and this is a PLA. The PETG runs at a hotter temperature, but even at that you still have to experiment around a little bit, both with PLA and with PETG. It's always good to put some parts on there and do some test runs at some different temperatures and different speeds. Once I get a good speed where it's printing well and the temperature's good and I've got the stringing under control, then I'll push it to the limit. I'll start pushing the speed up. And sometimes with speed, especially with PETG, sometimes you also have to increase the temperature some proportionally. But and then I'll check and watch the quality. If the quality starts dropping off, then I'll back down. But if I can get the parts to print, a set of 6 of these to print in 8 hours instead of 10 hours, that's an extreme advantage. And I want to do that, but I don't want to sacrifice quality, because these parts have to engage with this one and fit into it through these slots right here. And also these ports are threaded and have attachments that screw into those 1/4 inch threads. So if you get too hot with the temperature and the filament starts doing a little sloppy job, those threads aren't going to come out as well. So a lot of reasons for that. One other thing on the Arnett or any printer that I have that has a non-magnetic permanent base that's of this hard material, they're normally porous to help adhesion, but too much adhesion, especially on a large part that has a large flat surface like this, you don't want too much adhesion. So you have to pay real close attention to how close the nozzle is to the surface, and you can't just go by, you have to check the printer, you've got to do your leveling and your test with your paper, adjusting the pressure between the head and the build plate, and then you have to do that with the nozzle and the build plate at operating temperatures. Normally it's 60 degrees, 200 to 220 here, and once you get at those temperatures, a couple of things. You know that there's not a little bit of filament left on your nozzle that might otherwise, if it's not heated, affect your leveling and positioning of that head. And another thing is if you get in there and set it up when it's cold, you come back with a heated bed, and it may be a few tenths of a millimeter different. The heat itself can cause some of these printers to change, and you'll find that you're either printing too high or too low. A lot of times when I start printing the first time on a job, I'll have an outline around the print work, and as it's printing that outline, I'll just feel it with my finger, and I can tell by the feel of it if there's just enough that just enough ridge there for the proper setting. If it feels too smooth, then I know the head's too low and I need to turn these clockwise and lower that bed a little bit. I'm putting too much pressure on that filament, on that head when it's coming down this side. If the hump feels a little high, or if the filament's loose, then I need to open these up and raise this side a little bit. So even once I get started running one of these things, I'll still sometimes do some adjustments on the fly on that first print cycle, just to make sure that I've got it right. And if you aren't sure about that, or your part isn't there, then just go out and do a little drawing that just has a little border type and perimeter and maybe an inner square, and put that print job on and run that just as your first thing. And it may be something that only runs in 5 minutes, and in 5 minutes you can make those fine adjustments until you know it's good. Then clean your bed off and start your regular print job. So those are a few tips, a few things that I picked up along the way I wanted to pass along. Hopefully they'll help you out, and we'll have more to come later. Thank you for watching.